Okay, we are starting days 14 and 16, which is solving rational equations and solving radical equations. And like I've said, we're spreading everything out just to make this go a little bit easier for you guys at home. So we are going to spend 2 days on solving rationals, and that is, we know what a rational graph looks like. It's a fraction of polynomial functions, right? It's a polynomial over a polynomial. So as you can see here, now we have equal signs in there, and we have a bunch of polynomials divided by polynomials. Now some of these can get a little bit tricky, so we're actually going to start with question 5, just because it's a little bit less intense. Okay, so this is where we're going to start for question 1. So what we're doing here is we are solving for an x value that when we plug it in, this left side equals this right side. Okay, so if x equals 1, does the left side equal the right side? If x equals 2, does the left side equal the right side? If x equals 3, does the left side equal the right side? So that's our goal. So there are a few approaches to solving these, and I'm going to do my best to make it as simple as possible. Okay, and it's going to be hard to do because these just aren't simple problems. So first step is we want to get a common denominator. Think about back in elementary school or junior high when you learned to add fractions, you needed a common denominator. So that's going to be our goal here. So if you look on the left side, if we want to add this and this, those denominators aren't the same. So what we have to do is have them be the same. So that's when we multiply by a value, or in this case an expression, that makes the denominators what we call the least common denominator. Okay, so this has an x in common, this has an x minus 3 in common, so our least common denominator between those two will be x times x minus 3. Okay, that's the lowest. So to make this one x times x minus 3, we're going to multiply top and bottom by x minus 3 over x minus 3. Remember, whatever you do to the bottom, you have to do to the top, because otherwise you change the problem and you change the value of that. We don't want to do that. Okay, and then with this one, I think we want to multiply by x over x to make it look like this. Okay, so when I do that, I multiply numerator times numerator, denominator times denominator, and I'm not going to distribute those through because there's no reason for us to do that. Okay, and you'll see why. In the next one, we have x times 1 all over x times x minus 3. Now at this point, we can add those together, right? X minus 3 plus x gives us 2x minus 3. And now what we've done is we've created one fraction on our left-hand side. Okay? Now, at this point, you can do a number of things. We have one fraction equals a fraction. We could cross multiply and solve. We're not going to do that. We're going to try to make this a little bit easier than doing that. So we're actually going to make the right side also have the same denominator. Okay, so what we have here is everything, both sides, is over x times x minus 3. Okay, now there's a few approaches you can do to get rid of those denominators. One is multiplying both sides of our equation by that denominator. And you can do this because you're doing it to both sides. If you do it to both sides of an equal sign, it doesn't change the value. What happens here? These cancel. What happens over here? These cancel. And you're left with 2x minus 3 equals x times x minus 2. Now, if you have a rational expression equal to a rational expression and their denominators are the same, do you think it's safe to say we can just cancel our denominators and go right to this? Answer is yes. Okay, so that's going to be our goal. It's going to make your life, my life, everyone's life here a lot easier. But if you do search online solving rational equations, or ask an older sibling, they might tell you, no, you have to multiply both sides by everything. Technically we are. We're just not going to show that every time because it's just going to get too crazy in our work. So if you get to the point where you have a rational equal a rational and the denominators on both sides are the same, you can just get rid of your denominators, okay? And just go right to our numerator, okay? It's kind of like how in logs, when we had log base 7 of an expression equals log base 7 of something, we just got rid of the log base 7s and set the insides equal to one another. Same thing, but you have to make sure in order to do this, your denominators must be equal everywhere. Everywhere, everywhere, everywhere. Even if you don't combine like we did from here to here, if the denominators are equal, we can just get rid of them with an equal sign. This is only true with an equal sign, okay? So don't just start getting rid of denominators everywhere, only with an equal sign. And at this point, you have an algebra 1 problem, okay, where we're just going to solve this. So you do see on the right side, if you did distribute that, at this point we are going to distribute that. You get x squared minus 2x. We are going to set this equal to 0 because we do have a quadratic. So I'm going to move everything over. And we're going to take our 2 factors of 3 that add up to negative 4. Set those equal to 0 and we get x equals 3 and 1. Now with rational functions and rational equations like this, you have to be careful with your answer. You have to go back and check what's called extraneous solutions, okay? What's an extraneous solution? It's a solution that shows up like this, x equals 3 or x equals 1, but actually doesn't work, okay? Why does it not work? Because it gives us an error in our domain. If you think back to last week when we graphed, or last 2 weeks when we graphed rational functions, think about this. Where would our vertical asymptote be? At x equals 0, right? X can't be 0 for that. So if we got 0 for an answer, we couldn't include it because it wouldn't work right here. Let's look at our next one. If we were to graph this separately, where would your vertical asymptote be? X equals 3, because that gives you a domain error, right? So notice in our answer, we got 3. It can't work. Why? Because if we plug it in to here, it's going to give us 1 divided by 0, which is undefined. Cannot work. So that's considered an extraneous solution. It's a solution that shows up, it looks like it works, but when you plug it in individually, it does not, okay? And if you look at the right side, if you think about that as its own rational function, where is that going to have any domain errors? Where is it going to be undefined? When x equals 3. So looking at these, if you got x equals 0, 3, or 3, cannot work. If it doesn't work in 1, it cannot work, okay? So our only answer here is x equals 1. And you can check it by plugging it in. 1 over 1 is 1. 1 over 1 minus 3 is negative 1/2. 1 minus 2 is negative 1. 1 minus 3 is negative 2. Does 1 plus negative 1/2 equal a positive 1/2? Yes, it does.